All right, so good afternoon. I'm Scott Stabile, and I would like to welcome you to the concurrent session on general biology and chemistry topics. In this session, we will have three presenters in two presentations sharing their research while in the START program. We'll begin with Sheri Lentz, who will be starting here soon. We'll be recording the session, so you're welcome to turn off your camera if you don't want to be recorded. Just as a reminder, if you aren't speaking, please have your microphone muted. If you have questions, feel free to type them in the chat while the speaker is speaking. We do have Ann Magnuson, the Associate Department Head of Math and Physics, on hand to monitor the chat and make sure that we see any questions that are brought up there. And then at the end of each session, we will also have time. For folks to unmute their microphones and ask questions that way too. So with that, I will turn it over to Sheri to present a little bit about the Monarch Meadow.
Oh, hi everybody. So I'm going to share my screen, and I put together a little presentation. It just may take a moment.
It does. Technology boost.
Yep. I think a hamster powers this one. So. Okay. Okay, everybody see it?
Yes, ma'am.
All right. Slideshow. And I apologize. It is just very, very slow. All right.
I think you're right about the hamsters.
Yes.
Look, they're spinning.
There we go. All right. So my project has been at Monarch Meadow, and it is a wonderful project that seeks to plant pollinator favorites, such as coneflowers, yarrow, and the most important to our cause, the milkweed. Right. So Monarch Meadow is important because alongside all these other flowers, the milkweed provides a home to where the caterpillars lay their eggs and can reproduce. Right. So the first day, I apologize. That should not have that. Okay. The first day that we worked, we cleaned out the little the offshoot gardens, and I'm thinking, yeah, this is all the animals we saw there. So we cleaned them out, and we transplanted some coneflowers and yarrow into the big meadow. And so when we were there, we found these little creatures, and right here you see the fire-belly newt, the green tree frog, and then this little brown anole. And signs of a good garden. But here's a little offshoot. And then the meadow is here. So it doesn't look like a whole lot right now, but we planted many, many, many flowers. And I'm really excited to see it in bloom. So as far as my own research, I decided to focus on the prevalence of the OE parasite, which stands for Ophiocystis electrospira, and that is also contributing to the declining monarch population in addition to the habitat loss. Now, these parasites are obligate, meaning they can only reproduce inside a living monarch. And once they're infected with parasites, they do not recover. And some of the spores on the abdomen of the butterfly are passed to the offspring when the queen lays eggs. Dormant spores that are on the outside of the female's abdomen are scattered to the leaves and eggs, and this is where the caterpillars eat them and it starts the cycle again. So I'm not sure why it ended there, but technical difficulties, I guess. So I did have more slides, and I honestly do not know what happened to them. So in addition to that, I reached out to the Monarch Project Monarch Health, and I'm going to stop sharing my screen. I can get back there if it listens. So I'm hoping it actually gives me the all right, I'm not seeing a little button to, there we go. Okay. No. Okay, so, right, I reached out to Project Monarch Health, and they sent me a whole kit for free about ways to sample these butterflies to make sure, they're free of parasites. But also they sent me the tape in which to gather the parasites and do it safely so I don't harm the butterfly or spread spores. So I think it's going to be a really, really interesting learning experience. I'm so excited. I can't wait to see the meadow in full bloom. And yeah, I just like being part of the solution. So I think that's it. Yeah. So if anyone has questions.
That's wonderful. Thank you, Sheri. I was learning stuff too. I didn't know about the parasites. That's
yeah.
fascinating.
Wait a minute, something's connecting. There we go. Got something. Recording has started.
I'll mute whoever that is.
This is Ann. I just wanted to report, I don't know if you have the chat window up or not, Scott, but I don't see any questions as of yet. I do see a comment that says, I love that frog. Yeah. So cute.
Frog was very cute. Yeah. So I did have a question,
Sure.
and I may have missed it a little bit. So you mentioned the parasite. How is the parasite related to the monarch meadow? Does the parasite grow better on certain plants, and we're trying to get back to more of a natural field to get rid of that parasite? I'm just interested in that connection.
Okay, so not necessarily. It can happen anywhere. I'm actually going to sample also butterflies I find in my yard and also at the Prairie Ridge Outpost of the museum, just to see if it's located, centrally here, but they very well could be at the meadow. It just depends on which monarchs come there.
Okay.
So, yeah, it's just very prevalent. But yeah.
I
don't think they're more, on certain kinds of milkweed or other plants. It's just, coevolution with the monarch, basically.
For monarchs.
Yeah. It's odd because it attacks them when they're in the chrysalis. And so sometimes they have trouble emerging. And that's what you saw the slide with the broken wings. And it's really sad. But, yep.
Any other questions for Sheri? Looks like Gail is typing something.
Well, I'll just add something. I had a couple last summer that didn't eclose properly, and I suspect that it was probably OE as well. For the most part, mine did pretty well, but it does happen, and we got to do it. And I'm so glad that Sheri was able to find a free source of being able to get the kits to do it. And of course, free is our favorite four-letter word.
Yes. Yes.
Of course.
Yes. And so I know I put the link in our Monarch Butterfly Teams meeting slot, so anyone can go in there and request a packet, and they send it right away. Really helpful.
Mm-hmm.
One of the hard parts about Monarch Meadow is that the majority of our work is in the summer and early fall. And so our spring semester is really all spent with maintaining the meadow and the demonstration beds. So it's like we don't really have data yet, but we will.
Yes. Definitely will. I'm going to continue through the summer.
Yeah.
Very good.
Yep.
All right. Well, Sheri, thank you very much. I don't see any other questions popping up. If anybody has questions for Sheri that pop up in your heads, feel free to pop them in the chat. But thank you so much for your hard work, Sheri, and great presentation. It was great to see those great pictures.
Yeah.
Uh,
Thank you.
and hear a little bit about the work you're doing and working on. So thank you.
You're welcome.
All right. And so our next presenters are going to be Ian Mercer and Sarah Chavis. Ian and Sarah have been working with Ajit Dixit as their mentor. They are not here with us live, unfortunately, so I will be playing a video that they recorded about their project. If you have any questions, feel free to type them in the chat. We can certainly work to share them with Ian and Sarah at the end. So I will go ahead and share their video and start that. All right, are people able to see the video? I get a thumbs up or a yes in the chat.
Yes.
Okay, good.
Yeah.
For spring 2021, our START project was chemical analysis of a mysterious substance in Wake Tech's HVAC system, composed of Sarah Chavis and Ian Mercer, with mentor Dr. Ajit Dixit. For the substance, it had a reddish color, solid and hard, with a crystalline structure. When it came to its solubility, it was insoluble in water and hydrochloric acid, but slightly soluble in sodium hydroxide and sulfuric acid. We noticed it changed colors after being heated from a reddish orange to a brownish black, meaning that it was most likely inorganic in nature. For ongoing work, we currently have a sample of the substance at NC State's EATS lab for analysis. They will be using methods of atomic absorbance spectroscopy, or more specifically, inductively coupled plasma spectroscopy, ICPS for short, to determine its atomic composition. ICPS is well suited for detecting metals and isotopes. What is happening is this substance is ionized by a very, very hot plasma, and when it is ionized, it produces electromagnetic radiation. That electromagnetic radiation is basically light, and what we are measuring is the wavelength of that light to determine what types of metals are in the substance. Pending results from NCSU's lab for this project will continue in the fall. Thank you for watching and listening.
All right. And I think I said that they weren't going to be with us, but it does look like Ian Mercer is here. So if folks have any questions, I certainly find this project to be fascinating. I was part of the first people to receive the information on this strange substance that they found in the HVAC system at Wake Tech. So I'm just very interested to see what the results are. So Ian, can you give us any more idea about about maybe, okay, so Anne has asked maybe how it was found. So how it was found, anything like that?
Yeah, so it was noticed in the HVAC system, which you probably conducted from the presentation. But other than that, we are not quite sure its composition. And without knowing its composition, it's a bit hard to tell whether or not it is something that should be focused on or something that is inert and not harmful in any way. So currently we don't know, but once we get results from NC State's EATS lab, we should have a lot more information to go on.
people are just fascinated by it too. So from Linda, so was it found on a filter or coating ductwork? Do you know?
That is a good question. Because of COVID, I was not able to go to campus and witness the environment that it was in. Sarah Chavis, she did, but she was not able to collect it. I think Dr. Dixit did that for us. However, there's a lot of things about those questions that can be important with the environment that it came from. For instance, was there moisture in the environment? If there was, then it could be some kind of bacteria, possibly, because that can be common with moisture in HVAC systems. But to be frank, I'm not quite sure exactly where it was.
I'm trying to remember. I saw a picture of it in its native environment, and it seemed like it was in a filter and an air handler of some kind, but I'm not sure exactly which one.
Yeah, it was in the HVAC system, but I wish I could give more of an analysis on on specifically where it was, but I cannot. It was on the North Campus as well.
Yes, found on the North Campus. Now it's going to be really interesting to see what it was, because I know it's certainly something that's flummoxed the HVAC people for a bit too. It's like, what is this and how do we handle it? Any other questions or comments for Ian? All right. If not, again, if you come up with anything, feel free to put it in the chat. We will make sure that they see what's going on. But thank you to Ian. And say thank you to Ian and to Sarah for their hard work on that so far. Oh, Kumadu wants to know if you've performed a flame test.
So what Sarah was able to do was she was able to heat it up in a crucible, and that is where we got the data of its color change when heated, and also gave us an indication that it's most likely inorganic. So if that's what you're alluding to, then yes.
Mm-hmm. All right. Does that answer your question, Kumadu? Yeah. Multiple people typing. We'll allow comments. You can always unmute and talk as well. Any specific color observed?
Yeah, it changed when heated from a reddish orange to a brownish black.
Of the material, and was there any specific color of the flame itself when it was put in the fire?
So it was just, to my knowledge, heated in a crucible.
Okay.
So we weren't able to analyze any kind of change in color in the flame.
Yeah, and Ajit mentioned that there was no gas available that day in the lab for the flame test, so no color flame test yet. But excellent work. Everybody's very interested to find out what it is, HVAC and beyond. So thank you so much. So with that, we can go ahead and finish up. So thank you so much to Sheri, to Ian, to Sarah for their great work. I'm going to go ahead and post the link to the program again. So if you want to pop into another session, there's still 10 minutes left. So if you want to go pop into one of the other sessions and see something else, feel free. Otherwise, the next session starts at 3 o'clock. So we hope to see you in those sessions. So thank you all very much.
Thank you, Scott.
Thank you